Today I'll be upgrading the open source 3D printed RC SkidSteer to complete this 3D printed course, which includes obstacles such as a pull-up bar. 1, 2, 3, 4. Ladies and gentlemen, welcome to day 1 of Mini Skiddy 3.0 revisions. And I've got this handy dandy whiteboard ready to go so that we can plan these upgrades with maximum efficiency. And if you can't tell, this is a drawing of the Mini Skiddy. Number 1 is updating the battery system. Previously, we were using one of these 2S LiPo batteries to power our Mini Skiddy, which works pretty well if you already had experience with hobbyist level electronics, meaning you already had chargers to go with it, and you weren't at risk of shorting your circuit board or battery and resulting in a very sad and not working Mini Skiddy. Nobody wants that. So, as per our whiteboard, I'm going to be updating our Mini Skiddy to not use that 2S LiPo battery, but instead use 2 of these lithium-ion Fenix batteries, which are fantastic because they have built-in circuit protection, overcharge and discharge protection, as well as a micro USB charging port built right into it, making it just totally user-friendly. To go along with the change of the Fenix battery, I'll also be incorporating a swappable fuse holder directly onto the printed circuit board. That way, if things just totally go off the rails, worst case scenario, you just pop out your circuit board, pop out the fuse, put in a new one, and your Mini Skiddy is back up and running like that. The one thing you may be wondering is why we're using 2 of these Fenix battery rather than just the one that we used in the mini dump truck. And the answer to that is more power, baby. So basically, the Mini Skiddy requires far more power than the mini dump truck does, and the mini dump truck was already riding on the edge of what was possible using one of these Fenix batteries. So there's just no realistic way to power the Mini Skiddy in a reliable manner using just one of these. Enough with the battery stuff. Moving on to revision 2, which is updating the front bucket system to make it easier to swap out attachments. Take bucket system swappable. To provide a little bit more detail, I ultimately just want to modify the front bucket attachment system so that instead of having to undo the servo and the wires, which can prove to be a little bit of a pain in the butt, instead you'll now just be able to pull the bucket directly off without moving the servo, and then either swap in the forks, or go from the forks to the plow, or go from the plow to Muddy Farmer's trailer hauling attachment, etc. We're gonna make this modular A. Finally, for revision number 3, we'll be making the Mini Skiddy capable of either 1, tires as you see here, or, drum roll please, tank tracks / treads so that you can truly turn your Mini Skiddy into a mini tank. To start, I laid out the design for the new PCB, which would use surface-mounted CR123A holders to house the Fenix batteries, as well as added the fuse holder. This is the snazzy new circuit board all soldered up and ready for some tests. For now, as you can see here, I'm gonna go ahead and jump into the CAD for the main chassis because I'm somewhat of a 3D modeler myself, and remove the 2 tabs that held the old circuit board on because we're not gonna need those anymore. This new circuit board is actually just a little bit wider, so it's super snug when you actually put it inside the chassis, so it's not gonna move side to side. The only thing that's actually gonna hold it in place is I'm gonna put a little slot clamp on the bottom, and then this will just slot down onto it, which will make it a lot easier to remove or put in place because it won't require any screws. Fast forward a couple days and I got the new chassis printed out. I also ran a couple tests with the new Fenix batteries, and I think it's going to work really well. I also believe we can expect longer runtimes from this build, as we're essentially using a 2S 700 mAh battery versus a 300 mAh battery such as the one we were using in the previous version of the Mini Skiddy. While I was at it, I also got on my computer and revamped the circuit board design just a little bit. One thing that is always a bit of a challenge with these PCB builds is I want everything to be swappable. That way, if you're building your own project, you can get an idea of what each part is in their own breakout board form. For example, this H-bridge is actually just centered around a DRV8833 chip by Texas Instruments, is in a nice little preformed package that is separate from everything else. That way, if you're building your own project down the line, you can just think back to right now and use the exact same part we're using in the Mini Skiddy, granted that your motors fit the current specifications of this chip. While this is great for getting an idea of what parts could possibly work on your future project, it makes it a little bit tougher when it comes to PCB routing, as instead of just surface mounting the DRV8833 chip in close proximity to where we need it, we instead have to make room for this entire breakout board on our PCB. One other change I made while I was optimizing the circuit board was instead of routing the power for the motors through the 5-volt buck converter, I instead just routed it directly from the batteries, as the motors can technically handle up to 12 volts, so I thought this could be a good opportunity to maybe get a little bit more power out of our motors. So we're gonna see how that goes. But enough of that. It'll be a couple weeks before our new board gets here, so while I wait for that, I'm gonna start working on our front swappable attachment system. I want the attachment system to be super user-friendly and not require any additional hardware. So the first order of business is figuring out how to securely attach the two pieces together. To do this, I took inspiration from a design done by Heart K on my Discord server, which uses dovetail ends to hold the pieces together and let them slide past each other. To prevent the pieces from going too far in one direction, I capped the top of the receiving attachment with a 45-degree angle, which prevents the servo holder from moving past that point as it acts as a dead stop. Where things really get crafty is now figuring out how to keep the servo holder from going back the way it came. And the answer to this is some kind of clip that can lock onto the attachment. Now, if you've ever tried 3D printing buckles, you'll know that it's absolutely critical to make sure that the force being exerted on the clip runs with the layer lines on the print. But trust me when I say I looked at this from every angle, and that just really isn't possible, at least in an easy way. So with that, my next best option was to create a clip that only had to move a small amount and could spread the bend over a long distance, hence this clip design. The clip only needs to move about 2 millimeters back, and it has 25 millimeters to do so. On top of that, to ensure the clip doesn't accidentally get pushed too far, it'll just hit the body of the servo holder, ensuring it doesn't max out and snap. You could of course pull it the other way and break it, but let's just say we're all a little smarter than the average bear, and we're just not gonna do that. So printing it out and testing it for the first time, I can actually say that it works pretty well. You can tell that the first rendition was just a little bit too loose. You can hear it rattle a little bit. And then if you were to really pull on it, more power than the mini skiddy could exert, but you know, power that I can exert, you can pop it apart. So I went ahead and decreased the tolerances by 0.2 millimeters so that that gap between the attachment piece and the receiving piece would just be a little bit smaller. And I got this, and this works. This is perfect. This is super snug. I will say that if your printer has different tolerances than mine, I'm gonna upload a couple different renditions of this. So one will be slightly looser and one will be slightly tighter, so that if your printer has different settings, you'll hopefully be able to find a fit that fits just right for your 3D printer. So with that, I'm officially going to check our make bucket system swappable attachment. I didn't put a checkbox, but I will now. Ooh, checked. And then for the battery system, I actually just got in my new circuit boards, so I'm gonna go ahead and solder those together, do a quick test, and we can check that box too. So testing on the PCB went pretty smoothly. I will of course be doing more tests, but just initially I'd say that was a tremendous pass. So I'm gonna go ahead and just cha-ching. So that leaves us with one last modification, possibly the most requested modification. Tracks. Now I've actually already done some deep thinking on this and printed out some test pieces to start messing with. For example, this little track, as well as I modified these hubs to fit the track. But pretty much what I'm thinking is I'd like to be able to run the tires on the same hubs that run the tracks. And so what I'm gonna do is where there's these indentations for the track to grab onto for the tires, I'm just gonna place extrusions along those same parts so that you can fit the tire over and it'll still have a nice snug fit and not be able to rotate side to side. For the track itself, at first I thought I was just gonna do a flat style like this, but then after doing a mock-up and placing a piece so that it has this raised triangle bit, just like a real skid steer, I think we can all agree that that just looks so much better, as well as just a lot more aggressive. So that's definitely the goal, and that's what I'm shooting for. After about 5 revisions, this is what I came up with. To achieve the triangle look mentioned previously, I created this roller support which screws into where the fender mounts, and then the second screw can be placed anywhere along this cutout to tension the track. The track itself has these thick lines with raised edges and small extrusions to add more traction. Most of the flexing happens at these super thin parts, which are sized at 0.6 millimeters. Driving around, you can see that the overall speed of the mini skiddy has greatly increased. This is due to one, I'm now routing the voltage directly from the batteries to the H bridges, which is giving us more juice, and 2, I spent a lot of time reducing the overall resistance in the system from the previous version. To put on the wheels instead of the tracks, all you have to do is make sure to install the internal drive belts and then just press the tires over the edges of the same hubs that are used with the tracks. Though I must say, if your goal is to achieve maximum off-road capabilities, I highly recommend the tracks. While I was adding the tracks, I also pretty much revamped every single part on the mini skiddy, starting with the arms, which now come out an extra 3 millimeters, which allows the bucket to properly clear the tires / tracks. 2, if you're looking for maximum torque and precise up-down control of the arm, I added this middle gear to the arm drivetrain, that further increases the reduction ratio. Instead of placing the pinion gear on the N20 motor facing outward, you can just flip it around and then take this middle gear and place it so that it meshes with both the gear coming off the N20 motor and the arm attachment gear. You'll then see the hole on the outside of the main chassis, as well as another support hole on the arm restraint piece, which with two 2x6mm screws, you can support that middle gear. Now I considered just using a 15 or 30 RPM motor to do this, but the problem with that is we're already exerting so much torque on the 3D printed pinion gear, and the only thing keeping it on or holding it in place is that little flat spot on the inside. So to ask that 3D printed part to deal with about 3 times the amount of torque just isn't the right solution. So by sticking with the 100 RPM motor and adding that middle gear, we're kind of divvying up the torque. Plus, if you know there's going to be young kids around moving the arm up and down, you can just eliminate that middle gear and put it how it was in the 2.0 version, with the N20 pinion gear meshing directly with the arm attachment gear. And while it still isn't great for it, chances are you won't break any teeth when you're moving the arm up and down. Or maybe you just want the ability to demonstrate by moving the arm up and down. One last major addition I made that I think you guys will love is headlights. I mounted them in the top of the cab, and they're the same style as the ones we used in the mini dump truck. They're then routed down into our auxiliary terminal block and controlled via the now updated controller, which in my case is my phone. So basically the button that was acting as the spacer between the up, down buttons for the arm, I transformed into the button that now turns the lights on and off, as well as added this nice little light icon so you know what it does. I've been enjoying this addition as it certainly adds a lot of character to the mini skiddy, and for retrieving your keys from under the couch, it is definitely the piece de resistance. So without further ado, I think it's time we take, ooh, it's snowing. I think it's time we take the now updated mini skiddy through the mini skiddy obstacle course.
Ladies and gentlemen, prepare to be absolutely amazed. Obstacle 1 is the purple block stack challenge. Essentially, you're trying to stack these purple blocks as high as you can so that you can reverse up onto them and over the ramp. I think we can all agree that in the end, the purple blocks were actually just a hindrance, and it would have been far simpler to just get up over the ramp itself. Moving on to obstacle number 2, which is actually just a flat straightaway. I was gonna put a box here for the headlights, but I figured the cardboard look wasn't really a great look. Crawling up the little ramp right there, that never would have been possible with the original tires. You can thank the tracks for that. And this is one of my favorite challenges. We're gonna go ahead and grab these little ramps, and you have to hook them onto the slots that are on this taller block section. And there's these little clips on the end that you can grab with the claw/bucket attachment. Now for sensitive viewers, I'd recommend looking away at this point, as the fall off of these ramps could result in a very early demise of our brand new shiny skid steer, but luckily I'm a pro driver, so I doubt that'll happen. Wow, I can't believe that actually didn't happen. Moving on to my favorite obstacle course, or favorite obstacle of the obstacle course, is this swing pull-up bar teeter-totter thing. And once you get a hold of it with the claw, it's just barely in reach for it actually, but then once you do get a hold of it, you can just pop off the platform and dangle like a berry. And from there, it's just a matter of generating a swing to get up onto the purple wall. And let me tell you folks, it is all in the bucket movement. Once you are up on the wall, it's as simple as just making sure to get both tracks on. As you can see here, I'm a little off kilter. But once you do have both tracks, you know, it's simply just a walk in the park. You can just climb right over and then gently lower yourself to the other side. I feel like this bears resemblance to Mission Impossible, but maybe that's just personal opinion. And right here you can see that I'm gonna utilize the quick swap attachment system. Wow, that was amazing. Wasting no time, we're gonna move on to our pallet loading test. And as you can see, I've got 2 precious cargo benchies that need to get loaded to the top shelf. And I may have been slightly ambitious here by putting the top shelf possibly out of reach of the mini skiddy, but never fear, anything is possible when you're dedicated. The tension is palpable. Oh! Alright, definitely gonna need to take 2 on that one. Nailed that one.
Up next, we of course have the mini excavator on the way, which I haven't forgot about, but I really wanted to get the mini skiddy buttoned up for peace of mind purposes. And for the how to build portion of the mini skiddy 3.0 model, I know my how-to videos have always been kind of lacking in some areas, as it's difficult to follow along with a YouTube video where you're constantly having to pause and replay and start the video to keep up with your own model while following along with the one that I'm building. So, in order to remedy this, I put together a step-by-step lesson guide, which you can access on my website, and I promise that you don't have to click through any forms. You can just click right into the lesson plan. There's no strings attached. But this way, each step can get broken up into its own little section and then be supported via photos and written material. Not to mention, if I make any updates in the future, it's way easier to go back into my lesson plan and change what you have to do versus basically not being able to change it at all with a YouTube video. So if you want to check that out, just hop over to my website, professorboots.com, and click over to the tutorials tab, where you'll see it pop up as either the only option if it's right after the release of this video, or if you're watching this in the future, it'll be one of hopefully many options. Then of course, if you feel like supporting the channel and funding future open source projects like the mini skiddy, consider picking up an electrical kit or a full complete kit with all the 3D printed parts if you don't have your own 3D printer. Once I have a rough idea on how many people are looking to get the 3.0 kits, I'll place a batch order for the PCB and PCB assembly, which will probably take about 2 to 3 weeks to get here, so first come, first serve on that account. Unless you're ordering in the future, then it could be as early as tomorrow. The only thing that doesn't come in the kits are the batteries to power the project, which I really like these Fenix batteries, which I'll put a link to down in the description below. You can pick up 2 of them, which is what you need for the mini SkidSteer, for about 13 to 14 bucks, so definitely worth checking out. And they just come, you know, they have the built-in USB charger. They're just excellent. For those of you looking to do this as a big group project and maybe you can't afford a whole bunch of these Fenix batteries, there's other options out there that are simpler. They just don't have the built-in USB charger or the protection circuits that I really like. That's all for this video, and if you haven't already, consider subscribing so you don't miss the release of the 3D printed RC excavator coming to a screen near you soon.